In this lesson, we will examine the option of using more than one variable when solving word problems. In this example, we have apples selling for 75 cents each and bananas selling for 50 cents each. Leela bought 20 pieces of fruit, and we want to determine how many apples she bought. Let's first solve this using one variable. Now, since the total cost of the fruit was $13, we can write the word equation, the cost of the apples plus the cost of the bananas equals $13, which we will write as 1,300 pennies to avoid using decimals. To determine the cost of the apples and the cost of the bananas, we'll apply the following formula. Now, to apply this formula, we need the price of each item, which we have, and we need the quantities purchased, which we don't have. Now, the question asks us to find the number of apples purchased, so let's let A represent the number of apples purchased. Now, what about the number of bananas purchased? What will that equal? Well, if Leela purchased 20 pieces of fruit altogether, and the number of apples is A, then 20 minus A must equal the number of bananas purchased. Now that we've expressed the quantities as algebraic expressions, we can apply the formula to determine the total cost of the apples and the total cost of the bananas. The cost of the apples will be 75 cents, the price per apple, times A, the number of apples. The cost of the bananas will be 50 cents, the price per banana, times 20 minus A, the number of bananas. This sum is equal to 1,300 cents. Now that we have an equation, we can solve it for A. First, we'll expand the left-hand side, and then simplify the left-hand side. From here, when we subtract 1,000 from both sides and divide both sides by 25, we get A equals 12. This means that Leela bought a total of 12 apples. Notice that an important step here was to recognize that if A is equal to the number of apples, then the number of bananas must equal 20 minus A. If we were unable to recognize that, then we could have also solved the question by using two variables. Let's do that. To begin, we can let A equal the number of apples purchased and let B equal the number of bananas purchased. Once again, we'll use the word equation and apply this formula to determine the total cost of the apples and the total cost of the bananas. The total cost of the apples will be 75A, the total cost of the bananas will be 50B, and these two costs must add to 1,300 cents. At this point, we have an equation, but we can't yet solve it for A since the equation has two variables. In fact, there's a rule that says if you have n variables, then you need n equations if you want to solve for those variables. So since we have assigned two variables, A and B, we need to write a second equation to accompany the first equation. To do this, we can use this information that tells us that there are 20 pieces of fruit altogether. So we can write the equation A plus B equals 20. At this point, we have a system of two equations. To solve this system, we can take the first equation and simplify it by dividing both sides by 25. Then we'll take the second equation and multiply both sides of it by 2. At this point, if we subtract the bottom equation from the top equation, we get A equals 12, which means Leela bought a total of 12 apples. Alright, now let's examine another question from a previous lesson. In this question, we are given information about the ages of Larry, Moe, and Curly, and we want to find Larry's age. Now, in the previous lesson, we solved the question using one variable. Now let's solve it using more than one variable. So let's let M represent Moe's age, let L represent Larry's age, and let C represent Curly's age. Since we have assigned three different variables, we will need three different equations in order to solve for each of these variables. Now to begin, let's use the fact that Larry is 5 years older than Moe. This means that if we take Moe's age, M, and add 5 to it, the result will equal Larry's age, L. Next, if Curly is twice as old as Larry, then if we take Larry's age and multiply it by 2, the result will equal C, Curly's age. Finally, we are told that the sum of their ages is 95, so we can write the following equation. At this point, we have three equations with three variables. Now we could solve the system and get the following results. But as you can imagine, this would take a lot of work. The point of these examples is to show that we can solve word problems using one variable or more than one variable. However, when we use more than one variable, it's possible that it will take longer to solve the resulting system of equations. So as a general guideline for solving word problems using an algebraic approach, it's a good idea to begin with one variable in mind, but if the relationships between the unknown values are complex, you should consider switching to more than one variable. Just remember that if you assign n different variables, you will need to write n different equations in order to solve for each variable.